placing it.
We need to review the route characteristics, specifically the clearances near this structure.
The power requirements for this section are critical.
Load calculation. .4 voltage selection specify system. Report. Environmental impact assessment evaluates electrification effects, including visual impacts and electromagnetic fields. Utility coordination identifies conflicts with existing power lines, communications, and pipelines requiring resolution.
Right-of-way acquisition secures property access for construction and ongoing maintenance activities. Land acquisition provides. Design engineering develops detailed construction drawings specifying pole locations and wire configurations.
242.10. Foundation design calculates required support for poles and considering soil conditions.
Pole manufacturing produces steel or concrete structures supporting overhead wire systems. Precisely fabricated. Steel pole fabrication welds tubular sections, creating tapered galvanized structures. Corrosion-resistant steel.
Concrete pole casting forms pre-stressed structures, offering durability and low maintenance. Reinforced concrete
substantial foundations transfer loads deep into the earth, preventing pole displacement from wind or wire tension forces. Foundation concrete placement pours structural concrete anchoring poles permanently. Proper concrete curing achieves.
All right, bring it down 50 centimeters. Hold it there, check the vertical alignment.
Insulator installation mounts ceramic or polymer devices electrically isolating energized wires from grounded poles. Polymer insulator fabrication creates lightweight silicone rubber alternatives offering vandalism resistance. Composite insulators
242.21. Messenger wire installation strings high-strength steel cable supporting contact wire throughout span.
Hold the tension steady. Control.
We are within the green zone for SAG.
Tensioning equipment applies precise loads, establishing correct wire tension and position. Proper tension may Section installation creates electrical breaks separating independently powered segments. Sophisticated insulators enable
Switch insulation in.
Grounding system installation connects structures to earth, protecting against lightning and faults. Comprehensive grounding prevents at 242.31. Lightning protection design addresses direct strikes, preventing damage to electrical infrastructure.
Turn current path establishes circuit through running rails completing electrical circuit. Proper rail bonding ensures adequate return current capacity.
242.33. Rail bonding installs connections between rail sections ensuring electrical continuity.
Straight current mitigation prevents electricity leaking from rails, causing corrosion damage. Isolation and monitoring.
242.35. Substation Kuchi builds facilities converting utility power to railway traction voltage.
Rectifier installation converts AC utility power to DC. For DC electrification systems, high-power rectifier.
The isolation sequence performed flawlessly.
Confirmed. We can proceed with the flexible configuration now.
242.23.
Feeder cable installation connects substations to catenary systems supplying traction power. Heavy-duty cables
Cable trench construction builds underground conduits protecting power cables from damage. Properly designed trench equipment.
Cable termination installation creates connections between cables and overhead system or equipment, and properly terminates.
Testing and commissioning validates electrical system performance before energization. 242 to envoy test make and it wing cleaning die fall. Insulation resist. Send.
That confirms section 242.47.
Adequate clearance verified.
Load testing validates substation capacity and electrical system performance under simulated demand. Key switch engaged.
Monitor voltage stabilization.
Levels rising systematically. Status confirmed green.
Understanding these high-voltage hazards is critical. Follow the operational procedures exactly as trained, especially the LOTO sequence.
Grounding clamp is secured and tested. Clearance is verified. Copy that. Proceeding with the hot stick operation now. Stay alert.
Maintenance procedures establish systematic inspection and repair schedules, preserving system condition. Preventive maintenance.
Vegetation management controls tree growth, preventing dangerous contact with energized conductors. Systematic clearing maintains
Contact wire wear monitoring tracks remaining conductor thickness. Systematic measurement.
Tension adjustment compensates for temperature effects, maintaining proper wire position year-round. Periodic
Structure inspection examines poles and foundations, detecting corrosion or damage wiring repair. Regular structural inspection.
Component replacement renews worn or damaged elements, restoring system to proper condition. Systematic component
Emergency response procedures address system faults and failures, minimizing service disruption.
Freight train approaching on track 2. Hold position until clear.
Roger that. Holding track 1 clear.
Arc damage repair addresses contact wire damage from pantograph flashovers, restoring conductor. Localized.
Align the primary connector now. Steady on the splice.
Connection secured. Switching the grid back on.
Ice accumulation management prevents dangerous loading from freezing precipitation. Monitoring and de-icing procedures.
Third rail installation positions energized conductor rail on insulators beside track.
Hoverboard installation provides protective covering over portions of third rail. Barriers protect the public and workers from accidental contact with energized rail.
Shoe gear designed up current and correction buttons reliably, robustly. Gap management address breaks in third rail at switches and crossings. Carefully designed gaps minimize interference.
2-rail versus 3-rail systems compare different third rail configurations, balancing performance and cost.
Bottom weakness. The catenary versus third rail comparison evaluates electrification alternatives. Overhead wire.
Historical significance recognizes electrification transforming railway operations over past century. Electric traction.
Early pioneers, including Pennsylvania Railroad and New Haven Railroad, demonstrated electrification viability.
Europe leadership established extensive electrified networks supporting dense, efficient rail operations. European
Japanese commitment to electrification enabled Shinkansen high-speed rail revolution. Comprehensive electrification supported.
Swiss achievement created 100% electrified network, despite mountainous terrain. Environmental benefits include zero direct emissions and reduced noise pollution. Electric operation eliminates local air.
Energy efficiency advantages demonstrate electric traction superiority over
242.80. Operational efficiency benefits include lower maintenance and improved reliability compared to diesel.
242.81. Performance advantage enables achieving higher speeds and acceleration. Cost considerations balance high infrastructure investment against lower operating expenses over time. Traffic density threshold determines economic viability, requiring sufficient train volume. Electrification makes economic sense only on routes with adequate traffic.
Passenger service priority favors electrification, providing clean, quiet, comfortable operations. Electric operation.
Urban applications strongly favor electrification, eliminating diesel emissions in populated areas. Metro and
elderlies. Freight challenges include lower traffic density and longer routes challenging economic justification. Freight electrification.
242.87. Partial electrification creates operational complexity. Dual-mode locomotives enable operation on electrified and non-electrified territory using onboard diesel.
242.889. Battery locomotive development explores diesel replacement on non-electrified.
Expansion planning identifies additional corridors justifying electrification based on traffic and environmental goals. Systematic analysis determines priority routes.
The overhead wires create such a visual impact.
Yes, but this design respects the historic and aesthetic values we need to preserve.
Public acceptance addresses community concerns about visual impacts and electromagnetic fields, stakeholder engagement, and
Renewable energy integration powers electric railways from wind and solar sources, achieving true zero.
The integration coordinates look good.
We're maximizing the renewable utilization for the railway demand.
Energy storage integration uses batteries or capacitors buffering demand and supporting voltage stability. Smart grid technology enables dynamic energy management, optimizing railway power consumption.
Corrosion protection addresses material degradation, particularly in coastal and industrial environments. Protective coatings.
Seismic design ensures electrical infrastructure withstands earthquakes in prone regions. Flexible connections and
242.103. Cold weather adaptations address ice, snow, and extreme.
Hot climate considerations address thermal expansion and cooling requirements in desert regions. Engineering adaptation.
422.15. Vandalism resistance protects accessible equipment from deliberate damage and theft.
Radio frequency interference mitigation addresses potential impacts on communication systems, shielding and threat.
242.109. Lightning protection testing validates design effectiveness, protecting infrastructure.
Long-term reliability demonstrates electrification providing decades of service with proper maintenance.
Life cycle cost advantage justifies initial investment through operational savings over infrastructure life.
Capacity enhancement enables more frequent service through improved.
International experience sharing advances best practices through global knowledge exchange, international cooperation.
242.115. Standardization efforts promote compatible systems in
Innovation is advancing electrification costs and reducing costs.
Future vision anticipates complete railway electrification, achieving sustainable zero-emission operations.
Climate imperative drives IVE's electrification as critical strategy achieving railway carbon neutrality, emission reduction.
Government support provides funding and policy backing for major electrification programs. Public investment recognizes
Economic development benefits result from construction, employment, and industrial capability. Major electrification
markets. Export potential enables technology transfer and equipment sales to international markets. Successful.
Connect the phase wire to the lug, making sure the torque wrench clicks when secured. Like this. Okay, applying the tag now.
Research advancement continues improving electrification technology and reducing implementation costs.
Public transportation transformation enables truly clean mobility through comprehensive rail.
242.5 lifetime. Sector 126. Legacy infrastructure represents decades of investment supporting